interesting function called the reciprocal function. What does reciprocal mean? Like if I said, what's the reciprocal of 3? What would you say?
-3.
No, that's the opposite. What's the reciprocal of 3? 1/3. It's when you flip it over. Good. So you remember when we did perpendicular lines, the slopes were negative reciprocals? So we both flipped it over and negated it, but I'm just talking about flipping it over, the reciprocal. So that's what this function does. F of x equals 1 over whatever you put in for x. Okay? All right, so it results in a very interesting graph. We're actually not going to have 3 key points for this one. We're going to have 2 key points and 2 special lines called asymptotes. Have you ever heard of asymptotes before?
Is it where it barely touches the x-axis?
Yeah, so you can see here that along the x-axis, the graph is getting very close. It never actually touches it, but it gets very close to it. Because when you plug in very, very large x values, like 1,000,000, you get 1/1,000,000th, which is a teeny tiny little fraction, but you never actually reach 0. So does anyone know the equation of the x-axis, by the way?
F of x is 1 over x.
That's the equation of the graph in red here. But what's the equation of this line, this horizontal line? It would be y equals what? 0. Very good. So y equals 0 is an example of something called an asymptote. We're going to have 2 key points and 2 asymptotes. Another asymptote on this graph is x equals 0. Does anyone know why this is an asymptote? Are you allowed to plug 0 into this function f? What would you get for f of 0? 1 divided by 0. What is that? It's not 0. Undefined. Remember, division by 0 is undefined. And a lot of times people get the two confused. Which one is 0 divided by 1 0 or undefined? They get confused. So one of my students taught me a way to remember, which is pretty cool. She said if you have a number divided by 0 that spells no, which means you can't do it, it's undefined. And if you have 0 divided by a number that spells on, as in right on, you can do it. So you get 0. But in this case, we're plugging 0 into the denominator, which we can't have a 0 in the denominator. So what happens is we get an undefined value. There is no function value. And so the graph ends up just kind of hugging that asymptote. So the only 2 points I need you to plot are the point 1, 1, because what's the reciprocal of 1? 1, right? 1 over 1 is 1. And what other number has itself as its reciprocal? How about -1? -1. If you take 1 over -1, don't you get -1? Yeah. So those are the 2 key points I want you to plot. Plot the asymptotes, and then just show that the graph is kind of going right along the sides of the asymptotes there. So when you're memorizing your key points, you're going to have 1, 1, -1, -1, but you also need to graph your asymptotes, x equals 0 and y equals 0. Okay? All right, so that's how you graph the reciprocal function, f of x equals 1 over x. Now let's look at how we might transform it. So for example, use transformations. So when I say that, I'm saying take the parent function and move it around to graph g of x equals 1 over x minus 2 plus 3. Okay, so again, normally you won't have the reciprocal function right there in front of you. I'll just say use transformations to graph g of x equals 1 over x minus 2 plus 3, and I expect you to be able to look into that library of functions in your mind and think which parent function does this match up with. And since this has a 1 over something, you say, oh, it's the 1 over x function. And then so that's the first step. So then you would say, okay, for 1 over x, I need to remember my 2 key points, 1, 1, negative 1, negative 1, and my asymptotes 0 and 0. And then you're going to look at the function and say, how is this function different from 1 over x? And there are how many differences in this case? 2. First of all, we're subtracting 2 right there. And then also we're adding 3, which equals 2 different transformations. So then we have to think about how does each one affect the graph. And what I encourage you to think about is what's on the inside of the function and what's on the outside of the function. So what do you think I mean in this case by inside of the function? The subtracting 2, that's right. You see how it's part of the fraction, like inside what we already had for the function? So whenever you're on the inner part of the function, it affects the x coordinate. So you know the subtracting 2 will affect the x. How will it affect the x coordinate? Plus 2, yes. Whenever it's on the inside of the function, it does the exact opposite of what you would think. So when it subtracts 2 from x, you actually add 2 to each x coordinate. Okay, so we know we're going to do that. Another transformation we're going to make is this one on the outer part of the function. The outer part of the function affects which coordinate?
The y.
The y coordinate, that's right. What's it going to do to the y coordinate? Exactly what it looks like. On the outer part of the function, it does exactly what you would think. We're going to add 3 to each y value. Okay? All right, so you're going to get in your groups now. I don't want to see a single person working by themselves. And you are going to try to transform this parent function into this new function g of x by altering the x and y coordinates. And don't forget about your asymptotes. So I'm going to turn on the lights. You get into your groups. Oops. So as you're doing this, I want to make you conscious of how you might be feeling about it. Okay? Because graphing is challenging for most people. It's very different from everything else we do in algebra. But it's important. It requires practice, and you're going to be uncomfortable most likely when you're first doing it. So I just want to reassure you, make yourself aware that you're getting uncomfortable and that it's okay. Because the more you practice, the less uncomfortable you will feel. But if you give up, that doesn't translate well on the test. So. Okay, so let's go ahead now, and first I'm going to transform each one of my key points by increasing the x, adding 2 to each x, and adding 3 to each y. So what did you get instead of 1, 1? 3, 4, good. Instead of negative 1, negative 1? 1, 2, good. How about instead of x equals 0 as your asymptote? X equals 2, and yes, y equals 3, because those are x and y values just like the points were. So now I'm going to, I actually always graph my asymptotes first. So I'm going to graph x equals 2. That's supposed to be a straight line. Theoretically, that's x equals 2. Y equals 3 is a horizontal line with all y values being 3. Then I'm going to plot my 3, 4, which would be here, 3, 4. And I'm going to plot my 1, 2, which would be here, 1, 2. Now, those points tell you, see how the asymptotes have divided the graph into 4 regions? And you know in your original parent function how it was in the upper right and the lower left quadrant. Same thing, and you can see that from your key points, which part it's going to be in. And then you just make sure that it hugs that asymptote on each side. It's going to get very close, but not touch. Yeah, I touched it. Darn it. Okay. right. Boop. All right, so it's going to go on like that. Okay. Now, actually, one of my students yesterday pointed out a neat little trick as far as moving the asymptotes. I thought it was cool. I've never thought of it that way. He said that he noticed that the asymptotes cross at 0, 0 in the original graph. So he just thought of it as moving 0, 0, which I thought was interesting. So he added 2 to the x and he added 3 to the y, and he said those asymptotes must cross at 2, 3. So here, 2, 3. And then he just drew the asymptotes through that point. It's kind of clever. Yeah, thought that was